All right, let's talk about cracking open the black boxes that pretty much run our entire world. We're going to see how you can take some of the most complex hidden code imaginable and turn it into a crystal clear blueprint. Let's dive in.
You know, from the power grid to the smartphone in your pocket, our world is literally built on software. But here's the thing. Most of it isn't the nice, neat source code that a developer writes. No, it's been compiled down into machine code, a language that's only meant for a computer's brain, which makes it feel totally alien to us.
So imagine you're a security analyst, and you get a suspicious file. This is what you're up against. Just a dense, intimidating wall of assembly instructions. It's the perfect example of a black box. You can see what it is on the outside, but you have absolutely no idea what's really happening on the inside. And it's a puzzle you have to solve.
And that really is the million-dollar question, isn't it? How do the experts take this digital chaos and turn it into something that makes sense? How do they safely peek inside that black box without, setting off a potential disaster?
Well, the answer starts with this really foundational concept called static analysis. This is basically the art of understanding a piece of software without ever running it. And as you can probably guess, that is absolutely crucial when you might be dealing with a nasty virus.
Think of it like this. You're a bomb disposal expert. You wouldn't just press the big red button to see what it does, right? Of course not. Static analysis is kind of like carefully X-raying the device first. It lets researchers map out a program's entire logic, find all the bugs or malicious bits, all without ever letting it run and cause any harm. It's the bedrock of modern security.
Okay, but trying to map out that logic from just a wall of text, that is incredibly difficult. So, how do we get from that state of total confusion to one of complete clarity? This, right here, is where modern tools completely change the game.
And here it is. This is the breakthrough. On the left, you've got that scary wall of code we saw before, but on the right, that is the exact same code, just transformed by a tool called IDA Pro. It's not a list anymore, it's a map, it's a flowchart. All of a sudden, you can actually see how the program is structured. I mean, the difference isn't just night and day. It's the difference between being totally lost in a forest and suddenly having a satellite map in your hands.
And the most beautiful part is how simple it is to understand. Think of it like one of those old choose-your-own-adventure books. The basic blocks are like the paragraphs you read, chunks of the story that happen one after another. The edges, those with the arrows, are your choices. If you open the door, turn to page 40. If you don't, turn to page 50. A split path is just a choice. An arrow looping back on itself, that's just the book telling you to reread a section. And just like that, the entire plot of the program is laid out right in front of you.
Okay, so you've got the map. Now, what if we could add another layer of clarity on top of that? Well, that's exactly where a decompiler comes in. It takes that super low-level machine language and translates it back into something that looks a lot more like the original code a human wrote. So now you don't just have the map, you have a translation of what's written on every street sign. It's an incredible boost to understanding for sure.
So now an analyst has a visual map and a translator. That's a huge leap forward. But here's the problem. Modern malware isn't built by one person anymore. It's built by huge, sophisticated teams. So to fight a team, you're going to need a team. It's time to scale up.
And this table just lays out the difference so clearly. You see, in an isolated workflow, the old way, analysts are constantly redoing work that someone else has already done. And when someone leaves the team, all their knowledge just walks right out the door with them. But in a collaborative workflow, everything is synchronized. Everyone sees updates in real time, work happens in parallel, and all that hard-won knowledge gets saved in one central place for the whole team forever.
I mean, the strategic benefits here are just massive. You're not wasting time on problems that are already solved. If one person figures something out, the whole team knows about it instantly. You get this single source of truth, a permanent knowledge base for the entire organization. And most importantly, you speed up your response time dramatically when every single second counts. Now, let's zoom out one last time. We've gone from looking at a single line of code to a whole team of analysts. But what are they actually protecting? Well, a lot of the time, it's the most important systems we have, our critical infrastructure. And the challenge here is just immense, mostly because the technology running our world is not all the same. I mean, think about this. IDA Pro supports over 60 different processor families, and that's not just some cool number to brag about. It's because a security team might have to analyze the code on a brand new smart device in the morning and then immediately pivot to looking at a decades-old industrial controller that's running a power plant in the afternoon. They have to be ready for absolutely anything. And listen, this isn't some abstract,
technical exercise we're talking about. This is about making sure our power grids stay on. It's about making sure railway signals can't be hacked. It's about securing our phones, our money, our defense systems. Reverse engineering is the key to proving that the digital code running our physical world is actually safe and secure.
You know, this quote really just nails the end goal perfectly. It's all about taking these incredibly complex, often totally opaque systems that we all depend on and making them transparent, making them understandable, and ultimately making them secure. It's about turning every single black box into a blueprint.
So, let's bring it all home. We've been on quite a journey here, haven't we? Scaling all the way up from a single, confusing instruction to thinking about the security of our entire global infrastructure.
We really started with just one analyst, staring at a screen of what looked like total gibberish. And by bringing in visualization and collaboration, we've ended up with a synchronized team of experts who can analyze, understand, and defend the very code that powers our civilization. That's a pretty remarkable leap in both scale and importance.
So I'll just leave you with this final thought. In a world that is built from the ground up on invisible lines of code, what could possibly be more important than having the power of sight? The ability to see inside, to understand, and to secure the very digital foundation of our lives.